Hello and welcome to lab. Today we're going to do experiment 19, electrolytic cells. This is essentially a gas law experiment and we'll be generating hydrogen in a tube and measuring that, and we will be using our power source here as our electricity generator. The key to this experiment to get good results is correct setup. So we're going to take a long time making sure our setup is absolutely perfect. In the first step, we needed to obtain some sodium carbonate and then add it to a stainless steel beaker. And then we'll add some tap water. Maybe about a 1/4 inch from the top. You can always add a little bit more later. And we will mix that. This is just to ensure that there will be a good electrical current flowing through our water at all times. And I think that's good. And then we'll place the stainless steel beaker inside of a plastic bowl for overflow. In our next step, we are going to make sure that our connections of what we're calling the flamingo wire, the copper exposed connections, are just sanded. They're all clean. And that looks good. And that also looks good. Then we're going to insert this part of the flamingo wire into the side hole of our rubber stopper. And then we're going to take our carbon electrode and press it down firmly. This connection here is the key to good results. If your flamingo wire is standing up straight, then it is a good connection. And then we'll place a screen over the top, and it doesn't have to fit in the holes. It just needs to be just over it. And all this is doing is when hydrogen is generated, it just directs the hydrogen up into the tube. In our next step, we're going to place this carbon electrode assembly in our stainless steel beaker. And we're just going to kind of lay it in there. And that looks good. And then we're going to fill our gas collection tube with water. We'll use our DI water bottle and we'll put kind of a dome of water on the top, and then take the fat end of a rubber stopper, place it over, and we're going to turn our gas collection tube full of water upside down and then place it underneath the water and then remove the stopper quickly. Now, I'm going to add a little bit more water so that it is totally full. And then I'm going to maneuver the gas collection tube over the top of the screen assembly. Don't get any air in there. I just did that. I'm going to move this over a little bit so I can set this on top. And I'm going to open the clamps, lower it a little bit. It's clamped well in there, and this is also clamped well in here. Okay, this looks excellent. I don't have any or a very little bubble at the top, and this part of the setup looks great. Now that our gas collection tube setup is done, we need to weigh and record the mass of the copper anode. Can you please record the mass? In our next step, we'll pour about 100 milliliters of copper sulfate into a 150 milliliter beaker. We'll place our copper cathode in the middle of it, and then we're going to hang our copper anode that you just weighed in the middle of the copper cathode. Sometimes it's helpful to elevate this on the whole apparatus on the stopper that we used for the gas collection tube setup, just so it's elevated a little bit. It should not be touching the bottom, and the copper cathode and the copper anode should not be touching each other. This looks good. Since hydrogen that will be generated will displace the water in the collection tube, I will set up the aspirator. Ready to just remove any water from the plastic bowl as necessary. Oops, there we go. Now I'm ready to hook up my power supply. I've plugged it in, and good technique is always turn the voltage and the current both to 0 before you start. Now that that is done, I can hook my alligator clip to my carbon cathode, and sometimes you may need to readjust things so that your carbon anode and your carbon cathode are not touching. And be sure when you use these alligator clips that you're pressing the plastic covering. Never press it like that. There will be a current running through the system, and we don't want to touch that. This looks good, and we can now put our red lead to the stainless steel beaker, and we can turn this on. Now, before I turn it on, I'm going to say a few words of safety here. Do not touch anything metal or the water while you've got current running through this apparatus. It is electrified and it will hurt. If you need to adjust anything, the easiest way is just to disconnect the clip on the beaker. So let's turn it on. Now I'm going to turn up my voltage and my current. And right now I'm aiming for a voltage, I believe. Actually, it doesn't matter what the voltage is. I'm aiming for a current of about 0.7. And as you can see, I've got a really good connection, so you can see that there is hydrogen generation, and it's coming off and it is collecting in our gas collection tube. So you'll get that going for a minute, and then I'll adjust my current. Sometimes it takes a little while for the generation to become steady. And again, just aim for a current of between 0.7 and 0.8. And it's kind of stabilized right now between those two values. And we can just let this go and not touch it for a while until our gas level is just slightly below the water. You'll have to turn on your aspirator once in a while to remove some of the displaced water. And this should probably take about 30 to 40 minutes. We started this, about 2 hours ago, which was exactly, 2 minutes ago, which was exactly 12 noon. So let's record that on our data sheet. Okay, it looks like our water level inside the tube is below the water level in the stainless steel beaker. So I'm going to disconnect this, shut off my power supply, and of course, good technique is to turn both the voltage and the current to 0. Now, what I'll do is I will keep this all underneath the water, move my rubber band down, and put my rubber band, make sure that the water inside and outside the tube are exactly the same. It's a little bit handy because the water inside the tube is still a little bit cloudy. Gives me a little help there. And there's my water levels are equal. So my water levels are equal. That means my pressures inside and outside are equal. I can remove the tube. All right, now I can fill this tube up to the level of the rubber band. Maybe pour a little bit out. And then I can always use my DI water bottle to be very accurate. I can pour it into my large graduated cylinder. And I can read the volume. Now, the smallest division here is in the tens, so of course we're going to estimate to the ones. I'd like you to read this volume. We also need to remove the copper anode. We'll dry it off a little bit with a paper towel. And I'm just going to let that sit on the desk a little bit, dry out a little bit more before we go weigh it. And we do need to read the pressure of the room and the temperature of the water. There's some water in the bottom of this bowl. It's not very stable, so let's read it here. And I'll hold it by this small rubber place so that my hands are not affecting the temperature of the thermometer at all. And we're just measuring the temperature of the water. Now that our carbon anode is dry, can you please weigh this? Okay, now that we're done, we can disconnect our other lead. We can return the copper solution back to the copper sulfate bottle. We can disassemble our carbon electrode assembly. And be sure you rinse that off. There's sodium carbonate in there, and it does seem to cake on everything. And we can just get rid of the sodium carbonate solution to the drain. Make sure everything is neat, cleaned up, kind of put together in the center for the next person. Thank you for being my lab partner today.